Okay. Hello, everyone. Thank you for joining. This is San Diego Superpass Meetup. Uh, kind of an exception in terms of the time. Uh, we are in 11 a.m. Pacific time and very late for our guests. So let's start going. 71 meeting, February 14. Happy Valentine, by the way. It is Valentine in US. So just quickly, if you're new to the meeting, we meet every month, sharing ideas just for 1 hour, having fun with C++. That's the purpose. The purpose is after 1 hour, you'll have more knowledge to do more with C++. If you have anything that you would like to share during the meetup, please approach me. I'll be more than happy to accommodate that. Okay, my name is Kobe. There is a Discord link here that you can take a look at. If you want Sea Lion licenses, please approach me through Discord or any other means. I still have coupons that I can share. Just remember the coupons, you go through the checkout process, punch the coupon, and then you get it for free. And my opinion, Sea Lion is that kind of the best IDE out there. Okay, so let's start with the main agenda. If you remember, I was showing this slide last meeting, introducing this book. I read the book. I really liked it, and fortunately I have the authors here in the call, which is a great opportunity for us to hear their thoughts and talk about the book. So I'm super excited to hear them. This is, one second, let me just do something very quick. 1 second. Okay, let me just. Okay. So this is the agenda. Basically, this is the C++ Myths, Debunking C++ Myths book. I'll let the authors talk about it in more details, but let me just introduce the authors. First, we'll start with Alex. Alex, born in Romania, 1977, seasoned software developer and the CTO of Mosaic Works. Say hi, Alex, so everyone knows about you. He has a passion for computer science since childhood, navigated various roles in multiple industries, mastering numerous programming languages and paradigms. Hopefully you like C++ the best. We'll hear about it. He has worked about 10 European countries, which is impressive, sharing his expertise as a programmer, trainer, and coach. He is engaging conference speaker, knowledgeable in geopolitics, culture studies, behavior psychology, and more. He actively contributes to the software craft movements and maintains strong presence through his blogs and published articles. He embraced his explorer archetype by continuously seeking new knowledge and experience. You can find there's some links of Alex's blog, Mosaic Works, and also Cura. And there's a Twitter handle there. Okay. Ferenc. Ferenc is experienced software developer. Say hi, Ferenc, so everyone knows who. Software developer based in Norway with over 15 years of expertise in system programming, software security, and application design. He has worked on projects involving autonomous systems, real-time traffic solutions, cryptographic applications, and proficient in C++, Qt, and embedded systems. He authored articles in C++ techniques, cryptography, and graphical programming for technical publications. Spare time, Ferenc contributes to open source projects, participate in programming contests, enjoy exploring his cultural heritage through cooking, shares traditional recipes to inspire by his roots. LinkedIn profile is also on this page. that's it. I'll stop sharing. Folks, you can grab it. You can grab the screen.
All right. I think I will start and then Ferenc, because I have a few things. Let's see. Right. I don't have anything to share actually. I didn't prepare slides or anything. Okay, sorry. But first of all, I'd like to say thank you for having me. It's great to be joining you. I'm 6,000 miles away in the Mosaic Work Studios from where I'm recording every week videos. And it's great to be, tonight, or at least tonight for me. And I have to start by saying that despite this being my fourth book that I authored or co-authored, it's the first time that I'm actually doing something like this, kind of a virtual book tour. So I don't know exactly what to do here, but the only inspiration that I have is that I watched a lot of book tour sessions by Stephen King. Only Stephen King is not doing programming, and I'm not as good as him as writing things. But he likes to tell some stories. So let me tell you a few stories. I started my interest in computers when I was 10. This was when I first read a book about computers, and those were not very present back then. This was communist Romania. We had some computers, but they were in a large industrial, like communist industrial complexes. They weren't available. You couldn't go near them. But it was very interesting to me. It was fascinating. And this is what I always wanted to do. But the thing was, I was also very interested in writing and in a lot of other things. And if you've seen my bio presented before, it's been all over the place. I've been in multiple countries. I've been working with multiple technologies because I kind of like to explore things. Yeah, I have to mention, I grew up in Transylvania, which you probably heard about, with vampire stories. There are no vampires there, I'm afraid, but the stories are interesting. Anyway, I started programming with BASIC, then Turbo Pascal, and then C++. BASIC was on ZX Spectrum, a clone of that was built in Romania, and it was pretty interesting. There's a little bit of a story in the book about this. And I was really lucky that we got the revolution going on and the industry started developing. People needed programmers, so I was there. My first professional C++ experience was in Paris in 2000. And it was a basic, let's say, desktop application using a database. Only I made a mess of the design back then. I had no idea how to design software, and I had no idea how to preserve, how to prevent bugs. And after that experience, I really looked forward towards figuring out how to design software better, how to prevent bugs. And a few years later, after I finished this one, I worked with a guy from Belgium, which was partly in Belgium, partly in Bucharest. And he was really careful with how we were writing code. He would read every line of code. He gave us effective C++ and more effective C++ by Scott Myers. We knew all those rules by heart. And every time you would not follow one of the rules, you would get an angry email from this guy. It was not, let's say, a pleasant experience, but it was very formative. This is how I learned C++. And it really worked. We were building NoSQL database before NoSQL was a thing. NoSQL database engine. And that's the project that was formative. And this guy is, to me, the first mentor that I had. But after this, other languages came up, Java, C#. So I wanted to do some web. I wanted to do more or faster or better development for um, um, desktop applications. And these were technologies that really, in my experience, sped up things for me. And I wanted to explore the various ideas. I found these very intriguing. And that's how I got here in time. After being a developer for a while, then being a technical lead, then at some point I was a project manager, which was a mistake. So I quickly went back to technical stuff. And I've been software architect for a while, and then I decided that I really wanted to spend time with communities around Europe, with programmers, and teach a lot of the things that I learned. And it was part of this work is with C++ programmer, part of this work is with Java or .NET or a lot of different other languages. But you never forget the first language, right? And C++ is pretty unforgettable anyway. And so I was then approached to write a book on functional programming in C++, which was a few years ago by Pact. I wrote that one because actually I wanted to learn more about functional programming, and that's a really good way of doing that. And now, last year, we started discussions around this book about myths of C++. And I found this really interesting because I've wanted for a while to write a book of essays. And this is what I believe this is. We take various ideas, various assertions about C++, and we kind of go around them, examine them from different perspectives. And to some extent, it's us giving a definitive opinion, but on other, it's an invitation to readers to consider the things that we are discussing and to make their own opinions. And I think this is really cool. So I will end with the top 5 things I like about our book. First one is it has fun with the language. I think one of the things about C++ is that it's multiple languages. Different people use different subsets of C++. And we had a lot of fun playing with the language. But one of my favorite chapters around this is the chapter on multiple paradigms that you can use, because it takes you on a journey from provable programs at compile time all the way to forget about types and just do extreme polymorphism and try out all these different ways. I love that it's a collection of essays, as I said. As an example, there's a chapter about will Rust take over C++? And nobody knows, to be honest. It's very hard to predict that. I wrote down 4 things that I think, if they happen, Rust will take over C++. But it's really an invitation to everybody to consider this idea and what might happen. I like that it's for all C++ programmers, because there are all kinds of C++ programmers. We have people who know all the rules by heart, and they can quote you, well, undefined behavior happens in 10,000 situations. And we have pragmatists who just want to make things work. We have people who are more conservative, and they want to preserve the idea of the language and the core of the language. You have people who are progressive, would like to see things features from other languages coming into C++. We have performance geeks who squeeze the last picosecond out of algorithms. And it's great. And the book is occasionally touching on these subgroups, but it's also about the things that unite us, like what is C++ and how can we think about it in different ways. And I think it's current. It's one of the things that happened last year is White House released a memo about memory safety and the importance of memory safety for cybersecurity, and C++ was named as one of the languages that is non-memory safe. We're examining this in the book, and to my surprise, I found out that you can actually still write memory unsafe code even with modern constructs. And yeah, so it is a problem, and I know you changed administrations in the meantime. I don't know what will happen with this, but the problem is still there. And I think you'll have fun with parallelism and concurrency. We tried to show a few different ways to do parallelism and concurrency that are not the usual suspects. Functional programming and the actor model, which is really a nice way of dealing with these issues, and I think it's underused right now. And because it's C++ and we have off by one errors, I have the sixth one, which is it's easy to read. I think well, you could say I'm biased here, but honestly, this is mostly Ferenc's because he brought a really whimsical tone to the book, and that was really cool. So these were a few things that I wanted to say, just briefly, about the book. I'm looking forward to questions, and yeah, Ferenc, if you have any things to add.
You're muted.
Can you hear this?
Now, yes.
Yeah, finally. I was in the wrong window, definitely. I added a few bookmarks somewhere, so. Anyway, thank you everyone for joining us. And thank you, Alex, for building up a structure for what I'm supposed to say, because I really had no idea what to say before I joined here. But now I have a clear path. A bit of background history. The first years are very similar to what Alex said. Same country, same regime, almost the same school, 100 kilometers apart. Then a different university, actually. I didn't go to Bucharest. It was too far for me. So I ended up in a university much closer to my hometown. There I was introduced to C++. There I was introduced to Windows programming. So that's what I did for the first 2 years of professional jobs. Then I, like every other Romanian, started moving around the globe. I ended up in Cyprus, Israel, finally Norway. So here I am right now, doing all kind of interesting stuff, mostly with C++. Then, secondly, I want to apologize beforehand. I'm not as good in speaking as I'm in writing. So if I say something stupid, just bear with me. It's not intentional. And please ask as many questions as you want. Feel free to interrupt. It's okay. Then Alex laid out the basic idea of the book. It pretty much started the same, as he said. And we started gathering the ideas. What do I want to write? What do we consider would be fine to write? What can we actually write? That was decided by the people at PACT. So instead of the original 32 chapters, or how many did they have? Yeah, 32. They said, okay, it will be too long. So we ended up with 12. 12? Yeah, I think so. And Alex took half of them. I tried to do the other half. I hope I succeeded to some extent. And yes, now here we are discussing the book. My favorite part of the book is actually the one which I did not write. It's the one that Alex wrote. It's about memory safety and those kind of dangerous things. Because I have this quite strange interest of breaking programs to see how they fail and how can I make them much more safer. Actually, I have a book I got with me. I started with this. You can't see it. No, you can see it. No, you cannot. Anyway, it's a book from 2001, 2, depends. Yeah, it's an old book, 25 years old. And that's what got me into this C and C++ safety related programming. And I pretty much used that book as a base for all my work I did recently. But what I have found very strange is that basically this was the last good book about safety and C++. And I started wondering why. Because, yeah, we all know that C++ is not that safe. But what happened since that book came out and today, when we have almost 0 books pointing in this direction? Actually, there are a few. 24 deadly sins of software, but that's more general if I remember. Anyway, in my opinion, what happened is that modern C++ came out with features specifically designed to address these kind of problems that made this book relevant. No, that book is not relevant anymore, so we have this book. This is what we wrote, and in it we found it a bit difficult to find concrete safety problems for C++, because it's very, all the new features that were introduced were exactly pointing in those specific dangerous situations that were very relevant 15 years ago. And from this point on, what can we say? Do we have safety issues in C++ or not? Certainly, if one wants to write code which returns a dead reference to someone, then yes, you can write it. But the safety is already built in the language. So I'm not afraid for C++. It will not disappear. And I don't know if Rust will take over or not. Hopefully, both of them will coexist in a very good programming landscape in the coming years. Right now in 2025, if we can trust something called the TOB index, that is something that makes the popularity of programming languages as per their usage in various projects. C++ is on the second place. So we still have relevance for the language. And what else can we say about C++ safety and relevance? Questions?
So I have a quick question. I don't know. I read the book, and I'm not sure everyone. I think we have a few coupons, but I don't know if people had the chance to complete that. So there is a lot of emphasis in the book on what happens before and after main, for example. So you probably know that.
Yes.
So what was the trigger to have a lot of emphasis? And there is a tool that I wasn't aware of. I'm familiar with objdump and similar, but you using a different tool name with start with a G,
Gidra.
Gidra. Yeah. So I wasn't aware of this tool. So what actually triggered you to have an emphasis on this part? Like, did you see a lot of issues? Did you see a lot of, or maybe lack of knowledge gaps in the community?
Actually, I remembered our C++ course at the university where our teacher clearly said that your program starts at main. Okay, it was not a very well-constructed course because it did not deal with global objects nor static whatever. So this somehow stuck with me that, okay, main is where your program starts. And recently I more or less discovered that it is not true. Your program does not really start at main. Obviously, from C++ point of view, there are the global objects, but there are more things that are outside of this C++ language, which are very operating system dependent. And I always was interested in this kind of low-level stuff to see how they work, what binds them together. And possibly this was why I thought that including this kind of information in the book is something relevant and useful. And sorry for drinking, I'm thirsty. So if we look at the construction of the executable files from a very low level point, it's just bytes, basically binary instructions. And what makes them a program is the operating system. Linux deals with this one way, Windows the other way. And I found it very confusing what to make of this. So I did some research, and the result of that research is that specific chapter in the book.
Yeah, there's a lot.
Yeah.
There's a lot of I think maybe gaps. I found that chapter and everything that surrounds that topic very unique in the book. That I it's very hard to find it in other places in the written literature. So I found it very useful in the book. I think it's something very unique.
Yeah, thank you. I tried to find information from basically everywhere I could find. And indeed, this kind of information is not that present in the books, mostly in help files or readmes or how-tos or, yeah, just reading through the source code of Linux.
Yeah, yeah, yeah. That's the fourth. I'm looking at the table of content, and I can see that that's the fourth chapter. If anyone wants to jump to that,
Yes.
that's the one I'm talking about.
Yeah, and if I may add something, it's you can read the chapters in any order you want. They are not related. So if you find one interesting, you can jump to it. And yeah.
Sure. Yeah. Yeah. I agree.
Yes. Some chapters, at least from my point of view, sorry about it, but I made them intentional to be as crazy as possible. For example, the C++ is beautiful. That contains some really, really weird code that I picked up from the International Obfuscated C Code contest. If it works for C, then it works for C++ too. And there you can find some really interesting syntax issues that most books simply don't cover.
Yeah. Is anyone? I might have more question, but I'll let others ask.
Mhm. Well,
If no, I have
yeah.
another one, like
Okay, thank you.
another question. So, you have a reference to Kate Gregory. There is a very famous talk from Kate about teaching C++. So there's a reference to this in the book. Can you tell me, for your experience, like, since you are very seasoned C++ engineers, when you have junior, uh, intermediate, in experience, and junior folks working with you, how do you bring them up to speed? For example, 25 years ago, when you worked on, and there was efficient and more efficient, more effective C++, I think the language was smaller. Today, the language is bigger. There's a lot of rules to remember, and you actually mentioning few of the cumbersome rules, like for example, initializing with curly braces, like the uniform initialization versus not, and there's a lot of things to remember. How do you approach it? Like, how do you teach people in your company, in your surrounding? What do you think is effective? Going back to what Kate Gregory said, she said, don't start with C. Teach C++.
Yeah, so that was one of the chapters that I wrote, and to me it's very interesting to look at teaching methods, because this is one thing that I do. Now I have to mention, mostly what I'm teaching is advanced techniques. It's more about software design, it's about preventing bugs, architecture, things like that. But I gave some thoughts to, and I had some people who wanted to learn a programming language who asked for my help. And so I'm looking at the different ways. And I think in this chapter, we talk about Kate Gregory's method, we talk about Bjarne Strustrup's structure, and we talk about a method that I have used and which is honestly my favorite, particularly to take people from a level of knowledge where they know syntax and basic C++. But first, I think if I were to start a team now with C++ developers, the first thing I do, I would recognize that C++ is many languages. And instead of trying to cover everything about the language, I would try to figure out what is the dialect that we want. What are the things that we will use in our code? Because if we want really high performance, like very fast trading, high frequency trading stuff, of course you need to go into a lot of low detail. But if you are doing some kind, like some of my clients, they are doing engineering applications, performance is interesting, but not as interesting. It's more about being able to structure the code, transfer data, and stuff like that. So it's other types of challenges. So based on those challenges, I would pick a subset of C++ and the paradigm to use. And then I have seen in practice in the software craft communities that you have mentioned, the power of teaching through automated tests. I think it's something that we are not using to its full extent in the community. But if you have this ability of writing a test first that defines what you want to solve in the code, and then writing the code, this already gives you focus on just a few small issues at a time. And it's a really good teaching method because you can learn one thing at a time instead of trying to understand tomes of 200 rules like I did. Right? It's much more focused. And as a teaching, as a learning experience, I think this is one of the best ways to go. Now, this requires a few things. It requires mostly a coach who can do this, who can explain. This is how we write tests. and then look at the code and say, okay, but we can also write this code in this way, and it will be better because of X and Y, because here we have some undefined behavior. But I think these two things are important. One is understanding what problem you're trying to solve, picking a subset, and then creating a learning flow. Anything else will kind of be very, very fuzzy, at least from my experience. It will lead to chaos at some point or others. I don't know, Ferenc, what experiences you have with teaching people. We haven't discussed about
Yes.
this.
I actually have the luxury to not to have to teach more than one or two people at the same time. And for me, all this happens in real life. So I'm not holding courses for 20 attendees. I sometimes get assigned a junior developer, and I just throw them in the deep water. Sorry. Here's this task. Write the code to parse a CSV file and create whatever we need out from it. They struggle with it. They learn a lot with it. And when they are done, I do a code review, and they are very unhappy about it. But this undefined behavior, memory leak, buffer overflow, fix. That's my very, very ugly method of teaching C++, but it works.
There is a follow-up question. Yeah, someone is raising their hand. Yeah, go ahead.
I know that Bolbaoca, you have said a lot about how there's a subset in C++ that you need to learn, and do not learn the whole language first, just trying to solve a problem based on that subset. So I am interested in the embedded system part of the C++, but I just don't know where to start with it. Like, what libraries should I learn, and what best practices should I adapt for the embedded system side?
Okay, so I don't have a first-hand experience with writing embedded systems, but I did play around with some things, and I work with people who are doing this. I think if you want to start, one of the best things to do is to imagine a very simple project and take it from the beginning to the actual deployment. So for an embedded system, it could be something that displays, I don't know, a line on a screen, or sends a signal, or lights up a bulb. I don't know exactly what, something very simple like that. And just try to write this up, and then come up with more and more complex scenarios around this. There is a very good book on, since I was talking about test driving code and how it helps, there's a very good book on test-driven development in embedded systems that can help with that as well. But it's better if you do it in a community with somebody who already knows how to write tests. The good things about writing tests is that the language required to write tests is much smaller. It's a much smaller subset than the language required to implement things. So it's actually much easier to write tests than to do the other stuff. And but with embedded system, there's a bit of setup that you need to figure out, and it's best if you have somebody to work with. Normally, in one thing I loved about software craft communities is you would always find somebody to pair program with. So if you are interested in things like that, search for the Slack group for software craft. It's in Europe, but you'll definitely find somebody to pair with there. There's a part of the channel that's especially for that. People asking for help. Can you pair program with me on this simple problem for 1 hour or 2 hours? And this is what will get you started. And then it's a lot of practice, I think, and reading books and getting feedback from other people, doing some more pair programming. Yeah. That would be my general advice now.
Thank you.
I see. Thank you. Because do you feel that you're working in quantum analysis, right? Like finance or C++ application. So what do you usually do when you encounter a problem, or maybe that you need to optimize the system?
Okay, so optimization is a very complex field, and I'm far from mastering it. It's and I think a lot of first of all, you need to figure out at which level you need to optimize. Do you need to optimize at the level of seconds, milliseconds, microseconds, picoseconds? You know, it's very important because it's completely different to optimize for these things. If you are in things like games, you can probably live with a little bit of time and, you know, some drop frames or things like that. But if you're doing high frequency trading, then those people are actually looking at cache, CPU cache hits and cache misses and stuff like that. So it can be really, really complex, and you need to know the ins and outs of processors and how they are using. I don't know many resources around that. Maybe, I don't know, maybe Ferenc, or if you know a book on optimization or something like that, it might be useful, but I don't.
Yes, there is a guy in Denmark who wrote a pretty good about C++ optimization, and I totally forgot his name. But if you give me 2-3 minutes while Alex can talk, I will find it.
Okay, so
C++.
so if you have another question, I'd be happy to answer in the meantime. Okay. Performance analysis tuning. Now I wonder how you practice this stuff. This is an interesting thought that just came to me. You probably need to actually work through some of the examples, because otherwise it's very complex.
I'm looking for another book
Yes, me too.
that is, it used to be my, around the beginning of 2000, it used to be my go-to. It was, I'm just trying to find it. Here, I found it. Okay. It's a very old book, but I really liked it. I'm gonna paste it. It used to be my, but this is very old, right? This is, let me see where it was. I read it. So this was 1999, and it still, believe it or not, it still has a very good suggestions about how to use C++, the standard template library and all. And I remember just buying it maybe the same year or maybe a year after that it was published. So I really like that.
Yes.
But it's old book.
So the author is Agner Fogh, Technical University of Denmark. Search for optimizing software in C++. Agner Fogh.
Okay.
Let me put it in here.
Okay, I see another question. Could you please emphasize a bit more on chapter 12? Rust will replace C++ from an embedded industry context. So as far as I know, I'm not I'm not aware of how far Rust has gone to embed it. I know Rust is is used now for systems programming. I know it is used in C++, in Linux. Starting getting used there. It's starting getting used in Firefox as part of various modules and things. But I honestly don't know a lot about how far has Rust gone into embed it. Yeah.
Hey, Punit. Yeah.
Yeah, to chime on the previous topic, I'm from Google on the Pixel side, Pixel phone. So we actively are transitioning to Rust
Oh,
on all the bootloader and on the base kernel side. So yeah, I mean, at least on the Google front, I see a push towards Rust more than C++.
Wow.
Yeah.
Nice. Thanks.
uh,
Thanks.
can you share some of the reasons, or if they are not secret?
More towards, no, I mean, not really, more towards the compiler safeguarding you with a lot of stuff. Like, I mean, I've been pro C++. Like I worked at Rivian before this and Cisco before this using C++. And I'm not tied to any language as such. So I was like curious, okay, I have to learn. It's my job. So I was like working with Rust and I couldn't say no. But when I started using Rust, the compiler is like it. I mean, there are C++ compiler who warn you of unused variables, but like as simple as extra parenthesis, like if you have extra parenthesis like open and close brackets on an extra pair of it, it would complain that why have you used it. So it just like safeguards you with a lot of stuff than what an actual C++ compiler would safeguard you with.
Yeah. Yeah, I honestly liked. I've used Rust for a few projects, but not at Google level. Smaller, quite small projects, and I like what I'm seeing. It goes in the right direction in many ways.
Yeah, I mean, for example, yesterday I was just fixing something where there this one variable which I assigned a value to, but I was just printing it out, and the Rust compiler complains that, hey, you've not modified this variable, so uh, keep it as const or something like that. So it wants you all this tidbit stuff.
Yeah.
Thanks for sharing that, Punit.
No problem.
Okay.
Yeah.
Almost the top. Yeah, sure. Yeah. Come on.
I actually tried Rust 2 for a very quick project a year ago or so. I did not like it. So I stuck with C++, and unless a major change will come in for our company, then I think we will stick with C++. Our entire code base, 600,000 lines, is C++, and introducing Rust in that environment, we don't have the people to do it, and there is no will from the management to even start it. Yes.
Yes, Punit.
Yeah, I mean, just had a side thought. Like I learned yesterday, coming from the C++ world, you'll be really frustrated that Rust doesn't have inheritance in it. Like you can't inherit a class, or there's no feature called inheritance, and you have to make do inheritance in Rust.
That's okay, because I try to avoid inheritance in C++ if I can. So that's not a problem.
I mean, I used to use inheritance just for like mocking classes and all that stuff, and like
Mhm.
um with Rust, like I was like, who do I mock here? Like, and but yeah, I mean that was pretty weird.
Yes. Rust is mocking you.
Well, um, Okay.
Hello. So I see that Kuni, you were at Google. Is there a push for C++ to be using generated AI or machine learning in general? And what do you think about the machine learning aspect of C++, or mainly just Python?
So is the question, if I understand right? Can you repeat the question?
My first question was like, how is C++ using machine learning? And the second question is like, or is it majority C++ or just mostly Python programming for machine learning?
So is the first question more like, is C++ used on the machine learning side? Is that the question?
Yeah, but specifically the implementation of C++ on the machine learning side.
Yeah, I mean, I'm not the best person to comment on it, but I work on the Pixel phone. But at least on the Waymo side, the models are all written in C++ because of the runtime needs, for it to be like it's compiled, right? So much quicker. But on the cloud side, I'm not sure how it's done.
Yeah, I think since we were discussing this chapter about will Rust replace C++, I came up with 4 factors that could go there. And I can give you one spoiler, which is if we have Gen AI capable of translating from one programming language to another programming language, because we have a ton of C++ code, and it won't go away unless we are able to somehow translate it and not through people, because it will take, I don't know, a century or something like that.
Okay. 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 Thank you, folks. Kind of reaching the hour. So, is there anything else that you would like to ask in the remaining couple minutes? Closing notes from you two, folks? Anything you want to close on?
Okay.
Puneet?
What's the next topic? Like
What?
on the next meetup?
Oh, I'm gonna come up on the weekend. It happens usually on the weekend.
One final note from me, if you want to keep in touch, I'm on LinkedIn, but I also record a video every week, and you can find me on the YouTube channel Think Design Work Smart. One of the videos is actually about the memory safety in C++. We had a series of videos because there were many reactions on that. But it's not only about C++, it's also more about things that are happening in the industry.
Okay. Okay, thank you. Thank you both.
Yeah, thank you too.
Happy to have you here.
And
Thank you
buy
both.
the book if you have.
True. And thanks everyone for joining. Have a good rest of your day, good weekend. Happy Valentine.
Yes. Thanks a lot.
Take care.
And
Thanks.
bye
Thank
bye.
you.
Thank you, folks. Thanks. Bye bye.
Bye bye.